So here the daily mean wind speed in W knots was recorded at Heathrow during May 2015. And the data were coded using Z is equal to W minus 3/2. So whatever W was in wind speed in knots. That appears here. That wind speed was then 3 was taken away from that and then divided by 2 to get us a value of Z. So that's the coding. So we've understood the coding there. We're going to look at how the coding is applied shortly. But let's look at what we're given here. So the summary statistics we're given here are as follows. So we're given N is 31. Okay, so that essentially means that for this particular month, May, this is the daily wind speed. So there are 31 days in total. I'll just make a note of that so I understand the context of the question. Sum of Z. So that's all of Z added together, gives us 106, the total of that. And they've given us SZZ there. Okay, so that's a statistic there, which we can see is equivalent to this given to us in the formula book. Okay, and they've given it to us for the data Z. So the question then goes on to say, find the mean and standard deviation of the coded data. So it wants us to find out what Z bar is, because Z bar would be the mean of the coded data. Now to find Z bar, it will be the sum of Z, i.e. the total of all the Z values, divided by how many we have, how many values we have, so divided by N. So we need to know this mean is essentially the total of the data Z values divided by how many there are. We can work that out because we've got the sum of Z, which is 106 over 31. So that's relatively straightforward there. So if we go and work that out, it gives us a value of 3.419. We can then go and work out the standard deviation for this coded data. Now, since we are given a summary statistic here, 80.55, we can go and use that to work out what the standard deviation is. So they've given us that this SZZ value is 80.55. Now from there we can work out the standard deviation. There it is. It's SXX over N all square rooted. So if you want to work out the standard deviation, so I'll write down here sigma standard deviation for Z values is equal to the square root of SZZ all over N, which is equal to 80.55 divided by N, which is 31, all square rooted. And that gives us 1.6119. So there we have our standard deviation for the coded data, and we have the mean for the coded data. It then goes on to say, part B, to work out the mean and standard deviation of the daily mean wind speed at Heathrow. So the daily mean wind speed, remember, is the values W's. So we need to go and work out what W is. And we're not going to go and work this out by working out, we don't have the data for W. We have to go from Z and we have to go in reverse to find out what W is using our coding. So here's our coding. Z is equal to W minus 3/2. And we're expected to find out what W is. We have all the Z figures. Let's go and write down, rearrange that equation. So part B, let's write down our coding. Z is equal to W minus 3/2. Rearrange this for W, which will be 2Z, 2 lots of Z, plus 3 is equal to W. So this is how we would find W. W is worked out by doing 2 times Z values plus 3. Now we know how the mean is affected. So if I wanted to find out W bar, the mean is affected by both multiplication, division, as well as addition and subtraction. So to work out the mean of W bar, it will be 2 lots of Z bar plus 3. We already have Z bar because we worked that out here, i.e. the mean of Z. So it's 2 lots of that value there, 106 over 31, which was 3.419 plus 3. Okay, and that then gives us a value of 9.84 for the wind speed. Go and write down our units. Wind speed is measured in knots. So 9.84 knots here is what the mean wind speed is. Now we need to then go and work out the standard deviation, because the question asks for both the mean as well as the standard deviation. Now let's see how the standard deviation is affected. Now we said earlier, remember, that the standard deviation, so standard deviation of W is what we're trying to work out, will be equal to 2 lots of the standard deviation for Z, but the +3 doesn't affect it. Remember, standard deviation is not affected by plussing or subtracting, so this doesn't affect it. So where did I get this from? Well, I got this simply from the formula, the coding formula. W is equal to 2 lots of Z plus 3. But for standard deviation, adding and subtracting doesn't affect it, so the formula simply simplifies to standard deviation of W is equal to 2 lots of standard deviation of Z. And we already have the standard deviation for Z, 1.6119. So it's 2 lots of 1.6119, which is equal to 3.22. Okay, and again, it's knots.